We're going to look at some of the terms associated with diodes. The first one is the forward bias, and this is the bias voltage that's required to turn the diode on. So we need a certain voltage across that diode before it becomes that one-way valve. If we've only got, say, 0.1 volt on that diode, then it won't turn on and we won't get the forward bias. So we need a voltage source of about 0.5. If it's looking to get voltages of 1 or greater to turn on, then there's something wrong with the diode. So the normal value will be about 0.5, the abnormal will be greater than 1. The forward volt drop, once we get that current flowing through, is around about 1 volt. If we're reading more than 2 volts across that diode when it's conducting, again, there's something wrong with the diode. The reverse breakdown is the voltage at which the current will start to flow in reverse bias. Now it's going to take quite a big voltage for this diode. It's going to take about 1200 volts before we get current flowing this way. An abnormal value would be about 100 volts. So if there was only 100 volts on there and this started to flow in reverse, then the diode is faulty. The peak inverse voltage is the maximum voltage that the diode can withstand without conducting in reverse. So the normal value is about 1000 volts. We should be able to put 1000 volts on this diode and the current shouldn't reverse. The average forward current is the current that can flow through the diode all day, every day, without overheating the diode or breaking it down. And 1 amp for a 1 amp diode. If we've only got half an amp flowing for a 1 amp diode and it's overheating or breaking down, then we've got problems with the diode. The power dissipation and the junction temperature are related. We don't want this junction temperature in there to exceed about 40 degrees, so we want to keep this cool, and that's going to really depend on the current that's flowing through it. So we want to restrict that current and keep that temperature there below 40 degrees. If we do get some leakage current here going backwards, then we want to keep it to a low value. There isn't such a thing as a perfect diode or a perfect insulator. There'll always be some leakage current. Normal value would be about 0.05 microamps. So we can allow 0.05 microamps to flow in reverse without affecting the circuit operation. If it gets to more than, say, 50 microamps, then we're going to have problems with the circuit. We're going to have too much leakage current, and it may be that that diode is faulty.